Expressions. Simplify expressions with a distributive property. What are they? Sentence with a minimum of 2 numbers and at least 1 math operation. Why? Develops critical thinking skills. Interesting fact. Most ants are black or red in color, but some species are green or metallic. Here are the examples we're going to be talking about in today's video. Let's take a closer look at example 1. Now let's read the steps. Step 1, distribute. Step 2, rearrange the terms. Step 3, combine like terms. Now let's read the question. Simplify the algebraic expression 2 times the parentheses of 3x minus 5 plus 5x plus 2. Now we need to use the distributive property to simplify this expression. So when we do that, we need to multiply, or we need to distribute the number and the symbol that are in front of the parentheses to each term inside. Let's go ahead and get started with that 2, or that positive 2, and to distribute that to the first term, which is 3x. When we distribute, we multiply. So we have 2 times 3x, which gives us 6x. Now let's go on to the next term where we have minus 5. So we have 2 times negative 5, and that gives us negative 10, or minus 10. Now let's go ahead and bring down the rest of the terms. So we have 5x, or plus 5x plus 2. And now we're going to go ahead and show you a different way on why this is also the case. So that 2 in front of the parentheses represents how many 3x minus 5s we have. So in this case, we have 2. So we have 3x minus 5 in parentheses written twice. If you had a 5 in front, you would write 3x minus 5 times, but we have a 2, so we're going to go ahead and write it twice. Now we can go ahead and add the negative 5 plus the negative 5, which gives us a negative 10. We can go ahead and add 3x plus 3x, and it gives us 6x. Just another way of showing you why the distributive property works. So now we can go ahead and color coordinate the terms that are the same, so it's a little easier to see. Now we're going to go ahead and rearrange the terms, or like terms, so the like terms are closer together. And you can do that because of the commutative property of addition. And now we're going to add the 6 and the 5 together, which gives us 11. So we have 11x. And now we're going to combine the other like terms, which are the negative 10 and the positive 2. And that gives us negative 8. So we have 11x minus 8, and that is our answer. Now let's take a look at example 2, where we have 4xy squared minus the parentheses of 6 minus 3xy squared. Now you may be wondering, what do we distribute? Well, we're going to go ahead and add that invisible 1 so we can tell what number we need to distribute inside the parentheses. So once again, we're going to need to distribute that negative 1 to each term. And before we get started doing that, we're going to go ahead and drop the 4xy squared. And now we can distribute that minus 1, or the negative 1, to the first term. That is positive 6. So we have negative 1 times the 6, which gives us negative 6. Now we can go ahead and distribute it to the next term, which is negative 3xy squared. And we have a negative times a negative. As a result is a positive. And now we're going to go ahead and color coordinate the terms. We're going to rearrange the terms using the commutative property of addition. And now we can go ahead and combine the like terms. In this case, since 4 is positive, 3 is positive, we can go ahead and add the 4 plus the 3, which gives us 7, and this gives us our final answer of 7xy squared minus 6. Now let's take a look at example 3, where we have 10x squared y squared plus 2 times the parentheses of 3x minus 4x squared y squared. So once again, we need to distribute the number along with the symbol to each term inside the parentheses. And before we get started, let's go ahead and bring down the 10x squared y squared, because we don't have to distribute that to anything. Now let's begin the process of distributing by distributing that positive 2 to the first term, which is positive 3x. So we have 2 times 3x, it gives us 6x. Now we can go ahead and move on to the next term. So we have positive 2 times the negative 4x squared y squared, which gives us negative 8x squared y squared. Now we're done with the distributive property, so we're going to go ahead and color coordinate the terms. Now we're going to rearrange them using the commutative property of addition, so the like terms are next to each other. And now we're going to combine the like terms, so we have 10 minus 8, which gives us 2. So now we have 2x squared y squared plus 6x as our answer. Now let's take a look at example 4. We have 10x cubed y plus 4x squared times the parentheses of 3xy minus 2y squared. So same process as before. This time we're going to go ahead and bring down the term that we're not distributing. And now we're going to go ahead and begin that process of distributing the number and the symbol that are in front of the parentheses to each term inside the parentheses. And we can go ahead and get started with that 4x squared, which is the first term, which is 3xy. But as you can see on the left hand side of your screen, we have written the exponent for the x and the y, and that is the 1. And when we multiply exponents like this, we add the exponents, so we have x squared plus x to the 1, so we add the 2 and the 1 and we get 3, and so we get 12x to the power of 3 times y. And how do we get 12? Because of 4 times 3. Now we're going to go ahead and move on to the next term, which is minus 2y squared, and so that gives us 4x squared times negative 2y squared, and the result of that is negative 8x squared y squared. Now we can go ahead and color coordinate the terms, and since the like terms are right next to each other, we don't need to rearrange anything. And now we can go ahead and add the 10 and the 12 to give us 22, and so we have our final answer, which is 22x to the power of 3y minus 8x squared y squared. And now it is your turn, so go ahead and pause the video so you can take your time to answer these questions, and I will show you the answers in 3, 2, and 1. If you got them correct, well done. If not, there's always tomorrow.